Okay, Professor Jim Schultz here from my Finance 311 students. I wanted to go ahead and shoot a video going over a weighted average cost of capital problem. And so let's get right into it. This is one of your extra problems that I would classify as being a slightly more challenging problem. And so this is definitely a good one to know how to do and do well to put yourself in a position to dominate the final celebration. And so let's get right into this. So you have this Wacc problem right here that has obviously just a bevy of information, and I basically list all the info down here on the left hand side. And so basically what you're going to do, just like we've done in class, is you have this Wacc equation that's right here kind of in the middle. You basically just want to try to start putting together all those pieces, pretty much one at a time, and just handle things kind of independently, and then they will come together in totality to allow you to solve for a weighted average cost of capital. So let's go ahead and start solving these things. So I started by finding E first. You don't have to do that. You can find any of them first. It really doesn't matter. But I just was naturally inclined to go ahead and knock out E really quickly. And E is again found by taking the current price of stock times the number of shares outstanding. So that's your $23.50 times 4 million shares outstanding, both given in the problem. That gives you a total E of 94 million. So then I then proceeded to find D because I thought that would be pretty helpful now that I have E. So I find D by taking the current quote of the bond times the total face value of the bond. So the current quote is 101.4, which you see right here. And again, remember, whenever you see a quote, that is a percentage of par. So it's $60 million total in par, and then you simply multiply that by 101.4%. So it actually technically becomes 60 million times 1.014. And so that is 60,840,000. That is D. And then D and E together, I thought it would be useful to go ahead and do that addition off to the side. That's 154,840,000. So that is E, that is D. So then I went ahead and said, all right, let's find R sub E, or the cost of equity, or the required return on equity. Those are all the same thing, right? And so given the info that you have in the problem, you have a risk-free rate, you have a market risk premium, you have a beta, right? Naturally, you're going to want to use the CAPM to go ahead and solve for this cost of equity. So this right here is the CAPM formula. The only thing I want to point out is that the info in the problem is that the market risk premium is 6.5%. So that's right here, right? Remember, this parenthetical expression is normally RM minus RF. But remember, RM minus RF equals RMP, or market risk premium, which is 6.5%. So I just pop that guy right in there at 6.5%, and then you can knock out the rest of the equation, and you get 11.1% as your cost of debt. And then finally, as you scroll down a little bit, the cost of, I'm sorry, 11.1% is your cost of equity. The cost of debt is actually given to you in the problem. The YTM is 8.3%. Remember, the YTM on the bonds is equal to the cost of debt on the bonds, though those two terms are synonymous and interchangeable. It just really depends on which perspective you're taking. So you can plug that guy right in here at 0.083. And then obviously 1 minus t is going to be 0.75, as your tax rate is 0.25. And so once you do that, now it just becomes plug and chug, right? You plug in E, there's D plus E, there's R sub E, there's D plus E, there's R sub D, there's 1 minus t. You knock that guy through, come out with your results, add them together, you get 9.19%. So the WACC, the weighted average cost of capital for this company, is 9.19%. So this is how you solve, a fairly involved WACC problem. I hope you guys found this useful, and I'll see you guys for your final celebration.